Alright, so let's take a look at this type of an equation where we're solving a system of linear equations. It's a 3 by 3, and each equation has an x, y, and a z. And notice how it's set up, that the x's are in one column, the y's are in the middle column here, the z's in the last column, and the numbers on the right. And we need to start from that position each and every time. Most of the time they're going to give us the problem to us in this situation. Now, Mrs. Chambers created this chart and stuff to help students to make this problem the same solution, the same technique each and every time. Now, I'm going to add one thing, one idea, is that I'm going to look for in equation 2, I'm going to number these equations 1, 2, and 3. And if I have a coefficient of 1 in equation 2, that's the variable that I'm going to choose to eliminate. So I'm going to eliminate z. Because here it's saying to use elimination with equations 1 and 2. Well, some people might say, hey, I'm going to eliminate y because I'll just create a positive 4 and negative 4. But see, later when we use 1 and 2 and then use 2 and 3, that's why in equation 2, I'm always going to pick the variable that has a coefficient of 1 if possible. So let's use equations 1 and 2 and eliminate variable z. So I need in equation 2 for the coefficient in front of z to be a positive 3. So let's write down equation 1 as exactly as it is. 2x plus y minus 3z. And I'm going to put a 1 in front of that y just to help me. In equation 2, I'm going to multiply everything by 3. So I'm going to have 15x minus 12y plus 3z. And so as I don't make a silly arithmetic error, 3 times the negative 18, negative 54. If we add these two equations together, the z's are eliminated, which is exactly what we wanted. So here in column 1, the equation that I want to use is 17x minus 11y is equal to negative 73. Alright, so now let's look at our next column here. Use elimination with equations 2 and 3. Okay, so I'm going to erase that also. With equations 2 and 3 and eliminate the same variable as in column 1. We eliminated z, so we're still going to eliminate z. Okay, and this is a positive 7 here, so I would love in equation 2 for this to be a negative 7z. Alright, so in equation 2, let's multiply everybody by negative 7. So we have a negative 35, a positive 28, that negative 7 that we wanted, and negative times negative is positive, and 18 times 7 is what? 126. Equation 3, just going to copy it as is because it has that 7z that I wanted. So if I add these together, the z's are eliminated, which is what we wanted. Alright, so the equation that I have for here is this. Alright. So now it's telling us to use the equation from column 1 and the equation from column 2 and do elimination. Okay, I really don't see an advantage of eliminating the x's or eliminating the y's, to tell you the truth. So I'm going to eliminate the x's. Yeah, let's eliminate the x. Alright, so for x here we have a negative 34. We would love over here to have a positive 34. And 17 times 2 is a positive 34. Oops, times 2 is a positive 34. So if I multiply that equation by everybody by 2, then I can add this second equation here, and the x's will be eliminated. So that's my goal. So let's multiply everybody here by 2. So I get 34x minus 22y. And when I double 73, actually it's negative 146, isn't it? Now, when I add the second equation, let's see what we get. The x's are eliminated, and we've got 31 minus 22, which is 9, and 164 minus 146, 18. That's working out kind of nice now, because if we divide both sides by 9, we have that y is equal to 2. So then it says plug the number you just found into one of the equations in column 3. Okay, so into one of these. Alright, so let's just pick this top equation right here. We have found y to be 2. So we've got 34x minus 44 is equal to negative 146. If we add 44 to each side, we'll get a negative 102. So let's take that negative 102 and divide it by 34. I'm getting the x is equal to negative 3. So now we have x and y. Take the two solutions you have found and find the third. We can come back to the original equation and pick any one of these three variables. I would come back and pick equation 2 again, because I've got a 1z there. So let's get this out of our way. So if we pick equation 2, we've got 5x, but we know x to be negative 3. We've got minus 4y, but we know y to be positive 2. plus this z that we're trying to figure out, negative 18. So we've got negative 15 minus 8 plus z is equal to negative 18. If we add 23 to each side, we'll have our final answer here. We've got 5. So we found that the intersection of these three lines in three-dimensional space intersects at negative 3, 2, 5. And typically that's the order that you present it in as x, y, z. So hey, I hope that helps, and I'll talk to you later.